Okay, Assalamu alaikum everyone. Welcome to the class. So we started with classification and regression trees last time. So I would want to continue with that today. But before that, let me remind you of what we did very briefly. So we had this example that we were discussing. So we were talking about the studio that has received about 30 different proposals. And what they want to do is, without reading all of those proposals in detail, they want to categorize each of them into one of these three categories, that is critical success, mainstream hit, and box office bust. Right. And we said that for simplicity, what they're doing right now is they're only considering two different classes. So we have estimated budget and they have the number of A-list celebrities. ठीक है, इन दोनों variables के base पर they have to categorize each of those movie proposals as one of these three. ठीक है, either it can be a mainstream hit, it can be a critical success, or it can be a box office bust. ठीक है, so what we said was that as a start, we have two options. We can either uh, split on the basis of number of A-list celebrities, or we can split on the basis of the budget. So one possibility is that we split the data we split, with respect to the number of A-list celebrities, right? So we split the proposals on the basis of whether the number of celebrities were low, and the other possibilities, they are high. And we see what results we get out of that. So for example, in this case, if we choose to split on the basis of number of A-list celebrities first, what happens is that we get a tree like this. So we start from this node here. So हमारा सबसे पहला node क्या है? That is the number of celebrities. So that's what we start from. And that's our decision. Okay, so that is the first decision that we're talking about. And there are two options here. We can either have a low number of celebrities, so that's a low, or we can have a high number of celebrities, so we can have a high there. Okay, so हमने इसकी basis पर इसको split कर लिया. So when we split that on the basis of the number of celebrities, we have these two results. So when this is high, we have this categorization here. We have a certain number of critical success movies, a certain number of mainstream hit movies, and we have a certain number of box office busts. So low ke case mein, we have these different results. All right. So we look at it. Look at this data. Okay, we have 10 box office bursts here. We have one critical success and we have one mainstream hit. So we can say that whenever we have a low number of celebrities, since the majority of the movies are box office busts here, so we can choose to predict here on the basis of this majority category, and we could say that this is going to be a box office bust in this case. Okay, so this was a decision. यहाँ पे this will be a leaf node कि हमने predict कर लिया कि this is going to be a box office bust based on what? Based on the actual number of different categories we had in that region, right? The other possibility was that the number of celebrities is high. Now, in this case, what is the result? We have 9 critical success, we have 9 mainstream hits, and we have 0 box office busts. All right, so in this case, what would we do? We don't have a clear choice here. 9 आपकी critical success and 9 ही mainstream hits हैं. So majority vote में you do not have a clear winner as such, right? So what you would do is, if you were to just stop the tree here, and if you do not want to split any further, what you would do is you would just classify any one of these randomly. ठीक है, आप या उसको critical success predict कर देंगे या इसको mainstream hit predict कर देंगे, right? So you could do either of them. So let's choose the first one. So you could say we predict it as a critical success in this case, right? So this is how you would start building the tree. The other possibility could be कि आप इसकी बजाय what you do is you predict on the basis of the other variable here, and that is the budget. Okay, you could instead choose to predict on split the tree or start the tree on the basis of budget. So this could be the other possibility कि आप यहाँ पे your first node could be the budget, and you could decide on the basis of that if the budget is low, you would have some prediction, and if the budget is high, you would have another prediction. Okay. So what happens if you choose this split? So यहाँ पे you have an estimated budget of low on the left side and an estimated budget of high on the right side. So what happens if you have an estimated budget that is low? यहाँ पे क्या होएगा? Since the majority of these movies on the left side, they are critical success. So you could say that we predict these movies as critical success in this case. So we can have critical success here. ठीक है, तो इसको हमने critical success predict कर दिया because the majority category in this case was this one. On the right side, when the budget is high, the majority of these movies are mainstream hits. So since the majority is this, we say this is going to be a mainstream hit. Okay, so this is the process that we would follow initially. So we have two possibilities, right? कि हम या तो number of A-list celebrities पे split कर सकते हैं या फिर budget पे split कर सकते हैं. But the problem is, how do we choose which one of them is better? कि आप किससे start करें? Should we start with budget? Should we start with A-list celebrities? Now, a clear answer for this is going to come later on. But right now, you could just think of it like this. कब यहाँ पे देखें, how many movies are being wrongly classified? So if you look at this part on the left side, अगर आप इन सब को जो है critical success classify कर देंगे, these 5 are going to be wrongly classified, right? Similarly, on the right side here, अगर आप इन सब को mainstream hits classify कर देंगे, these 5 and this one, they are going to be misclassified. So overall, इस tree के अंदर we have 11 misclassifications, right? We have 11 misclassifications in total on this particular tree. और अगर हम पहले वाले में देखें, जो हमारे पास first possibility थी, in that case, यहाँ पे भी if you look at it, अगर हम यहाँ पे critical success हमने predict किया था इस case के अंदर, we have 9 misclassifications here. And in this case, we had predicted box office burst. So we have 1 here and 1 here. So again, we have 11 misclassifications here as well. So in terms of misclassifications, हमारे पास, we don't have a clear winner as such. So we could, let's say, choose any one of them. ठीक है? क्योंकि यहाँ पे हमारे पास कोई clear choice नहीं है, तो आप ये first split भी choose कर सकते हैं, second split भी choose कर सकते हैं, दोनों choose कर सकते हैं इस case के अंदर. So let's say आपने first वाला choose कर लिया, where we are basically splitting on the basis of the number of celebrities. So remember what the tree looked like in that case. So I'll just draw that again. जहाँ पे आपका number of A-list celebrities was the root node, जो आपकी first node थी, and then you had low and high categories there. Now the second thing could be that you could choose to split it further. So for example, यहाँ पे in this case, आपके पास अगर ये split है, the second one seems to be fairly good. कि यहाँ पे आपके पास 10 जो है box office busts हैं, and the other are fairly low, so it's a very high chance कि आपकी यहाँ पे majority predictions जो हैं, they are going to be correct. In the first case, in the upper part here, you have almost an equal number of mainstream hits and critical success movies. So यहाँ पे it makes sense to split this one further to improve the classification rate, so improve your accuracy. So what you could choose to do is कि आप इसके बाद एक और split कर लें, and you could choose to split on the basis of celebrities now, and you only do it for this part of the tree जहाँ पे आपकी A-list celebrities जो हैं वो high हैं, right? You'll see the exact tree later on in the next slides. So this is one possibility कि आप ये ऊपर वाले part को further split कर लें. So earlier you saw कि critical success और mainstream hit दोनों 9-9 थी. Now after you split it this way as well, you see कि आपके पास एक portion में you have all critical success movies and you have none other. So this seems to be fairly good. On the other side, you have 9 mainstream hits and only 1 critical success. So again, the majority of these predictions are also correct. So this seems to be fairly good in this case. So this seems to be a good option here. The other possibility could be कि आप ऊपर वाले को नहीं split करें, नीचे वाले part को split कर लें. But it turns out that यहाँ पे हमारे पास पहले क्या information थी? We had box office bursts that were 10 in number. We have 1 critical success and 1 mainstream hit. अगर आप इसको further split करते हैं, it turns out you have 5 box office bursts on one side, 5 box office bursts on the other side, and it doesn't really help you as much in terms of classification कि आप इस side को भी यही classify कर रहे होंगे box office burst और इस side को भी box office burst ही classify कर रहे होंगे. So the first split that we found here, that seems to be better. So that's what is shown in this case कि आपने पहले number of A-list celebrities पे उसको split किया. They were low or high. Low के case में you have a clear winner here कि सारी 10 out of 12 samples, 10 out of 12 rows are box office bursts. So आप इसको box office burst predict कर देते हैं. In case of high, आपके results क्या आते हैं? So this is the initial case जहाँ पे you have all of them equal to 10. You have 10 critical success, 10 mainstream hits and 10 box office bursts. But in the next part, जब आप इसको high के ऊपर split कर लेते हैं, number of A-list celebrities is high in this case. वहाँ पे भी you have a split like this. Okay, we have an equal number of critical success and mainstream hits in this case. So what we do is we choose to split it further on another variable. तो यहाँ पे हमने A-list celebrities के ऊपर split किया था. In the next phase, in the next step, we split it on budget instead, and we have 2 possibilities here again. We have low and high. When it turns out to be low, the budget, you see here, we have 8 out of 8 critical success. तो हम इसको critical success predict कर देते हैं. When the budget is high, we have 9 out of 10 main hits and only 1 critical success. So since the majority is mainstream hit, we predict it to be a mainstream hit in this case, right? So this is how you could build a tree like this. क्या majority categories के ऊपर उस तरह से choose कर लेते हैं. Division of 2 for 3 possibilities. Azhar, could you please explain that your question? I couldn't get it.
So मुझे clarify हो गया था बाद में.
Okay, good. Okay, so this is how you would basically build a tree like this. But now again, as we stopped here last time, we said कि the 2 questions that we have are कि हमें एक तो split कैसे करना चाहिए? So that is कि should we split on A-list celebrities first, or should we split on budget first? How do we choose which one we should choose, which one we should start from first? So यहाँ पे we have an intuitive understanding कि अच्छा, the one that is giving us a better split, we should split on that. But how do we define that better split? We need to have some sort of an objective criteria for that. And that's what we're going to discuss in the next few slides. And the second question is, when should we stop? So in this case, we stopped at this point because हम यहाँ पे इसके आगे further तो split नहीं कर सकते, because we only had 2 variables. हमने यहाँ पे इस side पे दोनों पे split कर लिया. But on the left side here, we could instead choose to split it further. यहाँ पे भी budget के ऊपर इसको further split कर सकते थे. But we saw कि budget के ऊपर इस side पे further split करने से we were not really getting anything better. So यहाँ पे देखें, अगर आप इसको further यहाँ पे इस side पे split करते हैं, on both sides we get the same prediction. So it's not really helping us as much. Okay? So we may choose to stop here. So this is another thing that we should decide कि हमें कहाँ पे जाके stop कर देना चाहिए. Because if we just keep building the tree, if we have, let's say, 10 variables, तो उसकी 10 layers बन सकती हैं on each of these paths. So हर path जो है वो 10 layers तक जाके extend कर सकता है. So we need to decide कि हमें कहाँ पे जाके रुक जाना चाहिए. ठीक है? So these are the 2 things that we need to consider. So the first thing is, how do we choose the best split, right? So इसमें एक चीज ये भी होती है कि you have different possibilities for categorical predictors. So यहाँ पे what we just discussed, we only had two possibilities. It's a binary variable. It can take one or the other value. Faiza, can you please turn that off? Okay. So in this case, you only had two options. It's a binary variable, so it's either low or high. But what if you have more than two categories in a certain variable? What do you do in that case? So that's what we have shown here. कि अगर आपके पास दो से ज़्यादा categories हो, you have three different options. ठीक है? So the first option is that you have all of those categories as the child nodes. कि आपका ये अगर root node है, for example, if you have in some problem you have a variable called income level, और इसकी तीन possible values हैं. That's either low, medium, or high. You could choose to have all of them as the child nodes. Okay, that's one possibility. The problem with this is when you have a very large number of possible values. So for example, अगर आपके पास एक variable है जिसकी 7 or 8 different categories है, 10 different categories possible हैं, you would have 10 child nodes here. And since we are deciding on the basis of कि हम जो चूज करते हैं कि कौन सा वेरिएबल हम सबसे पहले सेलेक्ट करेंगे, दैट्स ऑन द बेसिस ऑफ कि कौन सा वेरिएबल सबसे बेहतर स्प्लिट दे रहा है. जिसकी ज्यादा नंबर ऑफ कैटेगरीज होंगी ना, दैट्स गोइंग टू हैव एन अनफेयर एडवांटेज हियर इन अ सेंस कि जितनी ज्यादा कैटेगरीज होंगी, यू कैन एक्सपेक्ट कि उतना ज्यादा आपकी जो डिवीजन है फर्स्ट स्टेप में उतनी बेहतर होगी एज कंपेयर टू द अदर वेरिएबल्स. सो इट्स नॉट a fair match in that case कि अगर किसी वेरिएबल की दो कैटेगरीज हैं सिर्फ और किसी और वेरिएबल की लेट्स से 10 कैटेगरीज हैं, the variable that has 10 different possible values, that is going to be considered more important inherently by the algorithm. So that's a disadvantage in this case. But still, this is one possibility, and this is used very commonly as well. The other possibility is that you instead change these values to a binary outcome instead. So what you would do is you could for example make it a binary outcome like this कि आपके पास ये दो possible options है कि either the income level is low or it's not low, so everything else instead of low. because this could be one possibility. और इसी तरह से यहाँ पे low की बजाय you could have medium as well. So you could have, let's say, medium here and then everything else, high here and everything else. So एक तरह से आप इन categories को dummy variables जो आप पहले भी regression में भी करते थे, KNN में भी करते थे, these are sort of dummy variables. So this is the dummy variable for low income. You could have another dummy variable for medium income. You could have another dummy variable for high income. So high would be high in one case and not high in the other case. So everything else except high, and so on. So this is the other possibility, right? That you could create only two child nodes for this variable. One corresponds to a particular category, and the other corresponds to not having that category. That is everything else. This is the second option that you can do for such categorical predictors, and this is also very common. In fact, more common than the first one. And there's another third possibility that that in theory sounds to be the most likely to give you best results. लेकिन इसमें प्रॉब्लम ये होती है कि you have too many possibilities कि उसकी वजह से you end up having a very slow algorithm कि आपको बहुत ज़्यादा time लगता है उसको उस model को tune करने में. So what is this third possibility? The third possibility is कि instead of having a particular category and everything else, इस तरह से बाइनरी में कन्वर्ट करने के बजाय you look at all possible subsets. ठीक है, सो यहाँ पे फॉर एग्जांपल हमने सिर्फ 3 वेरिएबल्स बनाए थे. वन वाज लो एंड नॉट लो, medium and not medium, high and not medium. In this third possibility, instead of choosing just one particular category, you look at all subset of categories, all subsets of categories. So you would already have those 3. वो भी low भी एक subset है, medium भी एक subset है, high भी एक subset है. You have 3 subsets already from there. Then you could have some other subset, for example, medium or high. This is one possibility, and then you have everything else. You could have another subset, low or high, then everything else. You could have another subset, low or medium, and then everything else, right? So in this case, we have only 3 possible values, low, medium, and high. But think of a variable which has more than this, for example, 5 possible values, 6 possible values as a categorical variable. So uske jo subsets hain, they're going to be increasing exponentially. So it's very costly to choose this method. So even though it's going to give you the best results out of these 3 possibilities, but if you have some variables इनके number of categories बहुत ज़्यादा हो जाती हैं, वहाँ पे it's going to be these possible splits are going to increase exponentially. So that's why this is not used very commonly in practice. Okay, so the first 2 possibilities are the ones that are used most commonly. Then the second thing is, what do we do for numeric predictors? So ये तो हमने कर लिया कि categorical predictors के लिए we can do it like this. What do we do for numerical predictors? In this case, what we do is, okay, in fact, let me just write down some numbers here. So let's say you have a certain variable. So let's say you have that same variable, that is income level. And what you're looking for is, you have different values for that income level. So let's say this is in thousands here. So you have this variable income. It can take different values. So let's say you have 15K, you have 18K, you have 22K, you have 30K, and so on. Okay, so you have a lot of these different values. The first thing you would do here is you would sort these values. So abhi to maine already sorted likhi hai. So let's say 1,000 values and 10,000, 100,000 जितनी भी values हैं, you would sort those values first, and then you're going to split the data like this कि आपकी जो consecutive values हैं उनके आप midpoints find कर लेंगे. So 15K and 18K, इसका midpoint turns out to be 16.5K. And you have a midpoint here, that is 20K. And you have a midpoint here, that is 26K. So in this case, you are going to consider these different splits. एक आपका split हो सकता है, that is less than or equal to 16.5, या less than 16.5, and the other possibility is greater than 16.5. So this is one possible split, less than 16.5 and greater than 16.5. You could have another possible split that is less than 22K, and the other is greater than 22K. And you have the third possible split there, that is less than 26K and greater than 26K. And similarly, you could go on and you would consider all these possible splits, right? आप सारे जितने possible हो सकते हैं depending on the number of values you have, आप ये सारे splits consider करेंगे, and you will start with the one that gives you the best results. And how do we define those best results? We'll look at that in the next slide as well. But you could consider all of these different possible splits. आप ये node choose ये split choose कर सकते हैं, ये choose कर सकते हैं, ये choose कर सकते हैं. इन तीनों में से कोई भी choose कर सकते हैं, depending on which of them is giving you the best outcome. Okay. Any questions until here? Or is it all too easy?
Excuse me, sir.
जी तलहा।
सर ये हम एक वेरिएबल की डिफरेंट वैल्यूज या डिफरेंट कैटेगरीज के बारे में बात कर रहे हैं, राइट?
यस यस।
हम ये कैसे डिसाइड करेंगे कि ट्री के किस लेवल पे कौन सा वेरिएबल आना चाहिए?
Yeah, okay, so that's what we're doing, and in the next few slides we'll discuss that. अभी आते हैं उसके ऊपर।
ओके सर।
Okay, so if there are no questions as such, let's move on. So how do we decide which variable we're going to be choosing? अब जब आप split कर रहे होते हैं ना, what you want to do essentially is that you want to increase the purity of each node. Now, what does purity mean? Let me go back to this tree that we saw here. Purity को हम इस तरह से define करते हैं कि आपकी एक क्लास के अंदर, so for example, let's consider this node here, ये वाली जो estimated budget के बाद ये जो low वाला आ रहा है, इस node के अंदर you have all the movies that are classified as critical success. So you had 8 total movies. All of those 8 movies are classified as critical success, and there are no mainstream hits and no box office busts. This node is as pure as you can get in this case. So purity का मतलब क्या होएगा कि you have all the samples from the same category, right? So if you have all the samples from the same category, that means this node is the most pure, ठीक है? Because यहाँ पे you cannot get any better than this. This is the best accuracy you can get. So ये इसका मतलब है कि आपकी node has the highest purity. In another case, जहाँ पे for example, अगर आप your first case consider करें, where you have 10 out of 30 critical success, 10 out of 30 mainstream hits, 10 out of 30 box office bursts, this node is not as pure. In fact, this is as impure as you can get, because यहाँ पे कोई भी majority category नहीं है as such. All of them are equally likely. ठीक है? So इसकी basis पर your accuracy is not going to be very good. अब यहाँ पे initially अगर आप कोई भी randomly predict कर देते हैं, the accuracy in that case is not going to be very high. So purity is कि आपकी single class में single class के कितने ज़्यादा जो है वो samples हैं at a particular node. Okay, that's what purity means. So this would have a very high purity. This one, in fact, this one critical success यहाँ पे 8 out of 8, and this will have the highest purity. This one, जहाँ पे majority 10 है, you have one mainstream hit, one critical success. This is also going to have a very high purity, but less than this one, because यहाँ पे we still have some impurity in terms of critical success, one critical success movie and one mainstream hit movies. ठीक है? So ये आपकी 10 out of 12 आपकी correct classification है. So even though it's very pure, it's not perfect purity. So that's what purity of a node means. अब इस purity को जो है एक तरह से numerical value assign करने के लिए, quantify करने के लिए, we have 2 different measures that we're going to be using. ठीक है? I'm not going to go into too much depth into it, so you can I would say you can just ignore the definition here, because we don't really have a lot of time to go into the mathematics behind it. We'll only discuss how you can use this measure in practice. So let me have a look at the chat here. Yes, so purity is based on past data. Maybe the group becomes impure after testing validation. In that case, the group can change. Okay, so जब आप ये split decide कर रहे होंगे, so practically आप जो purity test कर रहे होंगे, वो आप validation data के ऊपर test कर रहे होंगे, right? So this is just for understanding जो अभी हम कर रहे हैं कि हमारे पास उस point के ऊपर इस तरह से division है. But when you're actually doing it in practice, ये जो आप test कर रहे होंगे, ये आप validation data के ऊपर test कर रहे होंगे. So that will work. अच्छा. So the first measure that you can choose, that you use for measuring this purity is called entropy. ठीक है? इसको entropy कहते हैं, and it's measured using this formula here. It's minus pi into log of pi. I will skip this slide and yeah, try to explain it from here. So think of it like this. You have a class. In fact, let me just copy this formula and go back to a previous slide जहाँ पे हमारा वो tree था, so that you understand it better. So how do I copy this? Yeah. Okay, so this is what the formula was. Sigma minus, ताकि minus अब बाही पे लगा सकते हैं वैसे, minus pi log of pi. What this, अच्छा सबसे पहले we need to understand what this pi means. Pi is basically the fraction of the fraction of samples, the fraction of observations you have from a particular category. So for example, अगर हम ये इस वाली को देखें, so let's consider this node here. Let's say इस node की आपने entropy find करनी हो, ये वाली जो node है, यहाँ पे log में आ रहे हैं. अब इसमें क्या, you have 3 different categories here: critical success, mainstream hit, and box office bursts. What do we do in this case? Pi corresponds to कि आपकी एक particular class के लिए उसकी fraction of observations कितनी है on this node. So for example, for critical success, this Pi is going to be 1/12. For mainstream hit, this is also going to be 1/12. For box office burst, this is going to be 10/12. This Pi ki value. So this is the fraction of values, fraction of observations you have from a particular class. That's what Pi means. So how do you calculate entropy for this particular node? You can calculate it like this. So this is minus sigma Pi into log of Pi. So आप क्या करेंगे? You have a minus outside here. Inside, आप इन तीनों values को 1 by 1 इसके अंदर input करेंगे और उनको add करेंगे. So the first is critical success. So you have Pi of 1/12. Then log to the base 2 of 1/12. Okay, so this is what you have for critical success. Then since it's sigma, that means you have to add it for the other categories as well. So mainstream hit ke liye bhi, we're going to repeat the same thing, 1/12 into log to the base 2 of 1/12. And again, we're going to add for the last category, that is box office burst, 10/12 into log to the base 2, 10/12. और ये हमारे यहाँ पे bracket close हो जाएगा. ठीक है? This is going to be the entropy for this particular node. Right? You can calculate it using some program. या आपका जब आप program कर रहे होंगे actually ये तो automatically calculate हो जाएगा. But this is what goes on behind the scenes. ये आपकी ये entropy calculate होगी. ठीक है? This is going to be some number here. What happens in this case? अगर आप ये वही entropy इस case के अंदर calculate करें, you see first one is 8 out of 8. So you start from here. So minus 8 out of 8 log of 8 out of 8 to the base 2. ठीक है? You add to that what? इसकी 0 out of 8 है, तो ये देखें 0 out of 8 into log of whatever, ये 0 रहेगा, plus 0 out of 8 into log of whatever, that's also going to remain 0. Now in this case, what do you get? This is 1, but then you have log of 1. Log of 1 is also 0. So essentially you're going to get 0 at the end, और ये आपका जो entropy की value आएगी, that's going to be 0. So whenever you have a perfect classification like this, जहाँ पे आपकी सारी values correctly classify हो रही हैं, you're going to have an entropy of 0 in that case. In this case, or in this case, when you have equal number of values from each category. That means you're basically as confused as you can get. In this case, जब आप ये entropy calculate करेंगे, for both of them, the value is going to come out to be 1 in this case. ठीक है? So entropy की value is going to vary between 0 and 1. 0 means it's the node is the most pure, and 1 means the node is the most impure. ठीक है? और आपकी values 0 और 1 के दरमियान में होंगी. The closer it is to 0, the more pure it is. The closer it is to 1, the less pure it is. So for example, in this case, since it's a fairly good, since box office burst has a fair majority here, यहाँ पे इसकी value जो होगी, it's going to be somewhere close to 0. ठीक है? It's not going to be exact 0 because perfect classification तो फिर भी नहीं है, but it's going to be close to 0, right? So entropy को you could think of it like instead of saying a purity measure, you could think of it as an impurity measure. कि जितनी ज़्यादा value होगी उतना ज़्यादा impure होंगे, जितनी कम value होगी उतना कम impure होंगे या ज़्यादा pure होंगे. All right. Any questions on this? So this is basically for calculating purity of a node. ठीक है? ये हमने सिर्फ अभी ये डिस्कस किया कि आप किसी भी नोड की प्योरिटी कैसे कैलकुलेट कर सकते हैं, राइट? नाउ वंस वी आर डन विद दिस, कि आप एक नोड की प्योरिटी कैसे कैलकुलेट कर सकते हैं. नाउ द प्रॉब्लम इज, आई एम नॉट गोइंग टू रेज दैट बिकॉज़ आई वांट टू गो बैक टू दैट स्लाइड अगेन, सो आई विल कीप दैट एज इट इज. जब आपने हर नोड की प्योरिटी कैलकुलेट कर ली, how do you choose कि आपको किस वेरिएबल के ऊपर स्प्लिट करना है? That was the question that Talha asked. For example, हमारे पास जो अभी जो एग्जांपल हमने की है, we had two possibilities. We could either split on the number of A-list celebrities or budget. Which one do we choose? आपको कौन सा पहले चूज करना है? पहले आपका कौन सा आना चाहिए, उसके बाद कौन सा आना चाहिए? So how do we choose that? We basically decide that on the basis of something that we call information gain. Something that we call information gain. अच्छा, यहाँ पे if you look at at the top right, so I can raise this part at least. अच्छा, so if you look at this part here, it means हमारे पास ये जो हम नोटेशन यूज करें यहाँ पे, n एक नोड है, ठीक है? n1 से लेकर nn, ये जितने भी आपके पास ये n1 से लेकर n2, n3, n4 and so on, all of these are notations for the children of this node. So children का मतलब है कि ये आपका अगर n नोड है, इसके नीचे you have n1, n2, n3, right? अब हर एक नोड की आप जो है वो एंट्रोपी मेजर कर सकते हैं यूजिंग द फॉर्मूला दैट वी जस्ट डिस्कस्ड. आप इस नोड की भी एंट्रोपी फाइंड कर सकते हैं, इनकी चाइल्ड नोड्स की भी हर एक की एंट्रोपी फाइंड कर सकते हैं, राइट? नाउ देयर इज समथिंग कॉल्ड एन इंफॉर्मेशन गेन, एंड दैट मींस कि आपको इस स्प्लिट करने से व्हाट एक्स्ट्रा इंफॉर्मेशन आर यू गेटिंग, राइट? एंड आइडियली what you would want to do is you would want to maximize that information gain. तो जो भी वेरिएबल आपको मैक्सिमम इंफॉर्मेशन गेन प्रोवाइड कर रहा होगा, you're going to split on that variable, right? And how do we calculate this information gain? आपकी एक एंट्रोपी होगी इस पॉइंट के ऊपर, right? That is h of n. यहाँ पे ये भी मेंशन किया हुआ है h of n, ठीक है? That is an entropy for this node. आप इसी तरह से इन तीनों नोड्स की भी एंट्रोपी फाइंड कर लेंगे, इन तीनों नोड्स की, राइट? एंड यू गोइंग टू सब्ट्रैक्ट फ्रॉम दिस पेरेंट नोड द एंट्रोपीज ऑफ ऑल ऑफ दीज थ्री नोड्स. आप इन सबको सम करेंगे और ऊपर वाली में से सब्ट्रैक्ट कर देंगे, लेकिन उससे उनको सम करने से पहले आप बेसिकली इनका वेटेड इनके वेट्स को कंसिडर करेंगे. यू आर नॉट गोइंग टू जस्ट डू अ सिंपल सम, यू गोइंग टू डू अ वेटेड सम फॉर these child nodes, और इन child nodes के weighted sum को आप parent node की entropy से subtract कर देंगे, ठीक है? That's going to give you the information gain. अब ये weights कहाँ से आएंगे? the weights are basically the proportion of observations you have in each of these nodes from this parent node. So for example, अगर आपके पास इस parent node की अगर let's say parent node की यहाँ पे हमारे पास total 30 observations थी इस parent node के अंदर, अगर 5 यहाँ पर आ गई हैं, 15 इधर आ गई हैं और 10 इधर आ गई हैं, the weight for this node is going to be 5/30. The weight for this node is going to be 15/30, and the weight for this node is going to be 10/30. ठीक है, इन सब के weighted sums लेंगे. अब in 5/30 multiplied by the entropy plus 15/30 multiplied by this entropy plus 10/30 multiplied by this entropy, इन सब के जो weighted sum आएगा, जो यहाँ पे ये mention किया हुआ है, इस weighted sum को आप parent node की entropy से subtract कर देंगे, and that is something that we call an information gain. ठीक है, so I can erase this part.
सर इंफॉर्मेशन गेन का फॉर्मूला थोड़ा सा रिवाइज कर सकते हैं?
Okay, so h of n corresponds to the entropy of this parent node. ठीक है, या जो भी आप impurity measure यूज करें, यहाँ पे आप entropy यूज करें तो यहाँ पे वो impurity measure आपकी parent node आ गई, उसमें से आपने subtract करना है weighted sum of the entropies of the child nodes. ठीक है, अब आपकी इस नोड की एक एंट्रोपी होगी, उसी तरह से कैलकुलेट होगी जिस तरह मैंने आपको शो किया पहले. इस नोड की एंट्रोपी होगी, इस नोड की एंट्रोपी होगी. उन सबको आपने वेट असाइन करना है बेस्ड ऑन द प्रोपोर्शन ऑफ ऑब्जर्वेशंस यू हैव इन ईच ऑफ दीज नोड्स. हमने कहा कि अगर ये 30 टोटल ऑब्जर्वेशन थी पेरेंट की, अगर इसमें 5 है तो ये W1 की वैल्यू क्या होगी? इट्स गोइंग टू बी 5/30. ठीक है, एंड देन यू हैव टू मल्टीप्लाई इट विद एज ऑफ n1 प्लस इसी तरह से आप सेकंड वाले की एंट्रोपी को मल्टीप्लाई करेंगे इसके वेट के साथ, that was 15/30 in this case, plus the entropy of the third node multiplied by its weight, that was 10/30 in the example that we just discussed. ठीक है, तो parent node में से आप इन सब को subtract कर देंगे, that's going to give you the information gain. So if I go back to that earlier slide, यहाँ पे हमारे पास ये ट्री था. In this case, we have, oops, okay, yeah, we have it again. So in this case, we have some entropy here. So let's assume, I haven't calculated it. आप ये calculate कर सकते हैं. So let's say this comes out to be 0.1. I'm just assuming this. अब let's say इस node की, ये किसकी entropy है? This is for this node here. ठीक है, box office burst वाली node की. This is 0.1, right? What is the entropy for this initial node? ये इसकी 0.1 है. Initial node में हमारे पास ये values हैं सारी 10/30 आपके पास critical success है, 10/30 mainstream है, 10/30 box office burst है. Let's say use the same formula for entropy. इसकी जब आप calculate करेंगे, this will turn out to be, its entropy is it's going to turn out to be 0.5. In fact, sorry, not 0.5, it's going to turn out to be 1 in this case because that's the highest entropy. और यहाँ पे हमारे पास equal number of values हैं from each class, तो इस case के अंदर ये 1 होगी आपकी. ठीक है, so we have an entropy of 1 in this case. We have 0.1 for box office burst. और ये दूसरा जो हमारे पास यहाँ पे split आ रहा है, that is 9/18 and 9/18. यहाँ पे भी इसकी entropy is also 1. ठीक है, because यहाँ पे भी equal जो है category, equal values हैं from each category. तो हमारे पास आ गई ये A-list celebrities ऊपर. So let me erase that part so we don't get confused there. So ये let's say हमने यहाँ पे सारी calculations कर ली हैं. We don't need this now. We also don't need this. So हमने essentially किया क्या है? हमने entropies find कर ली हैं for the parent node and also for the children. So we have an entropy of 1 here we said. We have an entropy of 1 here as well, because यहाँ पे भी equal है सारी values. We have an entropy of 0.1 here. We haven't calculated the exact value. ठीक है, let's say इसके around ही आती है, around 0.1. Information gain क्या होगा? आप इसका weight find करेंगे. आपके पास total कितनी values थी यहाँ पे? 30. 30 में से how many do you have here? You have 12. So इसमें weight क्या होएगा? It's going to be 12 out of 30. इसके साथ multiply कर देंगे इसको. You have 18 values here. So you're going to say 18 over 30 here, multiplied with 1. ठीक है? So information gain now is going to be entropy of the parent. So information gain is equal to entropy of the parent. That is 1 minus the sum of weighted entropies here. So that's 12 over 30 into 0.1. This will come out to be so 1 over 10, 12 over 300. That's 4 over 100. So that's going to be 0.04 here. And in this case, it's going to be 18 over 30. What will that be? That's going to be 0.6, right? और आपका information gain आ जाएगा 0.36 in this case. ठीक है? That's your information gain. अगर आप ये split choose करते हैं, that is the number of A-list celebrities. Now, you could also consider the other option जहां पे आपने budget choose किया था. अगर आप budget पे split करते हैं instead of A-list celebrities here. अगर आप budget पे split करते तो उसके लिए भी you would calculate this information gain measure. इन दोनों में से जो भी high होगा number, you're going to split on that. जो भी आपको high information gain दे रहा होगा, आप उसको choose करेंगे. इसमें let's say instead of just 2 variables, you had 100 variables, you had 50 variables. तो आप क्या करते? आप हर एक के ऊपर split करते, उसका information gain find करते. Whichever gives you the highest information gain, that will be the first variable that you choose to split on. उसके बाद you repeat the process for the subsequent nodes. आप यहाँ पे एक दफा categorize कर लिया, आप इसके ऊपर दोबारा से same process apply करें. You look at all the remaining variables. आपने एक तो already split कर लिया एक के ऊपर. You will now look at the remaining variables. उनमें से देखेंगे कि which of them is giving you the highest information gain. Next split उसके ऊपर होगा. And we'll keep going on with this process unless we choose to stop based on some reason, and that we'll discuss कि हम कब stop करेंगे. Or we'll just keep moving on and build the tree for as long as we can. जितने भी आपके variables हैं, जब तक आप सारे variables exhaust नहीं कर लेते on every branch, just keep moving on. ठीक है? या फिर आपके किसी point के ऊपर सारी सही categorize हो जाती हैं, you stop there. For example, यहाँ पे आपके सब सही categorize हो गए, so you don't need to split any further. So you either end up using all of the variables or you choose up getting a perfect split. So that's when you get a complete tree. ठीक है? जहां से आगे आप और कुछ split नहीं कर सकते. Does this make sense? Any questions here? Okay, so that's what information gain means. And this is how we can calculate it using that entropy measure. Entropy ke alawa, there's also another measure that is very commonly used. Again, you can skip where this formula comes from and how we get to this. But yahan pe, instead of that log of P, you have 1 minus P here. Okay, so Pi into 1 minus Pi. Again, it behaves very similarly to entropy, but this is another measure that you will see being used very commonly in practice. कुछ काफी सारे जो algorithms हैं, काफी सारी decision tree के implementations जो हैं, they use Gini's index as the standard, and many others use entropy as the standard. There's no clear there's no single choice here and there's no reason to choose one over the other as well. कोई इसका कोई set rules नहीं होते हैं इसके अंदर. Both of them behave similarly, but some algorithms you'll see choose to use Gini's index. Some other algorithms choose to use this entropy. ठीक है? इसमें भी it works exactly the same. It also ranges between 0 and 1. Okay, and the lower this number is, in fact, I'm not sure if it ranges from 0 to 1. The lowest value is indeed 0. The highest value could be, let me think about it. The highest value could go until, so if we have 0.5 into 0.5 and so I have something in chart here. Can we get to 1 here? So let me just think about it. क्या यहाँ पे 1 किस तरह हो सकता है? 0.5 into 0.5. Yes. So again, so this also ranges from 0 to 1. The lower the value is, the less pure is going to be. The higher the value, the lower the value is, the more pure is going to be, and the higher the value it is, the less pure it's going to be. So again, 1 means it's least pure, and 0 means it's most pure. ठीक है? So this is another measure. अब इसमें कुछ भी change नहीं होगा. आप सिर्फ entropy को replace कर सकते हैं Gini's index से, and then यहाँ पे information gain के case में you just replace entropy h of n की जगह. H हम use करते हैं entropy के notation के लिए, standard आप देखेंगे use होता है. Gini's index के लिए we use G, तो आप H को simply यहाँ पे G से replace कर सकते हैं, and everything else in this information gain formulas remains exactly the same. ठीक है? बाकी सारा process बिल्कुल same रहता है, उसमें कोई difference नहीं है. The second thing is, where do we stop? हमने ये तो देख लिया कि हम किस तरह से choose करते हैं कि किस variable के ऊपर split करना है, but where exactly do we stop building the tree further? Now there are two different things here, two different options here. जो हमने अभी discuss की पहले, whether we have no further features left to split on, and the other option is either we have no further features to split on, or we have we have all the training data correctly classified. अपने एक कोई ऐसी branch आ गई है जहाँ पे सारी correct classifications है. You don't need to split any further than that. But isme the problem is, if we just keep building this tree like this until we have one of these two conditions, the problem is the resulting tree that you would have in almost every case when you have a large enough data set, the resulting tree is going to be very large, and it's not going to work very well on new data because of this problem that we have discussed earlier many times, the overfitting problem. Because let's say आपके पास एक problem है, आपके पास एक algorithm है जहाँ पे आपको एक certain point के ऊपर ये classification मिल गई है कि you have 10 box office busts here, you have 1 critical success and 1 mainstream hit. अब यहाँ पे let's say you had some other variables as well. अब यहाँ पे क्योंकि कुछ classifications correct नहीं है यहाँ पे, so you have 1 out of 12, but you have 2 out of 12 misclassifications here. You could theoretically go on with building this tree until you have these correctly classified as well. अब अगर आपके पास और variables होते आप उनके ऊपर split करते जाते और आपको किसी point के ऊपर ये भी correct classification मिल जाती. But again, that would be that could result in overfitting, because it's very likely कि ये जो small number of critical success या mainstream hits जो यहाँ पे misclassified हैं, they are because of some random because of some random reasons, random variables जो आप capture नहीं कर सकते. अगर आप इन सब को एक को correctly classify करना लग जाएंगे अपने training data के अंदर, आपका जो मॉडल होगा that's going to become increasingly complex, आपका जो ट्री होगा that's going to become increasingly complex for the training data. जब आप इसको unseen data के ऊपर apply करेंगे, it's not going to work as well because of that same problem that we have been discussing, the overfitting problem. आप अपने training data के ऊपर अपने मॉडल को overfit कर देंगे, which is not going to perform very well and on the future data that you're going to get, right? So we need to stop somewhere in the middle कि आप, even though you can keep building the tree like this, we need to stop somewhere before that to avoid this problem of overfitting. अब इस overfitting को avoid करने के लिए we have something, we use something that's called pruning. Now, we have two different options here again. We choose either pre-pruning, and what that means is कि आप एक information gate का एक set जो है ना minimum criterion define कर लेते हैं. So for example, in our earlier example there, हमारे पास उसका split, उसका information gain आ रहा था एक node के ऊपर 0.36. So let's say you could define a criterion कि if any node, if we were to split any node further, if it gives us an information gain of less than, let's say, some predefined number, let's say less than 0.15, अगर 0.15 से कम information gain मिलता है, we will not split the tree further. ठीक है, हम एक predefined threshold value जो है वो रख लेंगे कि उससे कम अगर आपका information gain होगा ना, तो हम उसको आगे further split नहीं करेंगे, we just going to stop there. ठीक है, that's one option, that's called pre-pruning, कि आप पहले से एक threshold define कर लेते हैं. But in practice, pre-pruning does not work very well, and the problem with that is कि आप जब आप pre-prune कर रहे होते हैं ना, there are a lot of cases कि sometimes when you have a large number of variables, a poor split at some point, poor split means कि किसी node के जब आप split करें उसका information gain बहुत कम हो, that's called a poor split. In many cases, a poor split can have a good split after that at some point. For example, अगर आप tree को build कर रहे हैं और किसी split के ऊपर आप आके रुक गए हैं because the information gain is not very big, और आपने वहां पे उस tree को बस रोक दिया है, you might miss out on a good split that was to come out after that poor split. So there is a chance कि उस poor split के बाद कोई next split ऐसा होता that would be that would increase your accuracy in some way. तो अगर आप वो poor split पे रुक जाते हैं, आपने वो possibility जो है वो miss कर दी एक तरह से कि बाद में कोई better split हमें मिल सकता था. So in practice, what you instead choose to do is something that's called post pruning, and let's discuss what that means is. So this case is actually a short-term strategy. That does not work very well in practice. जो हम poor split के बाद एक good split जो है miss कर सकते हैं उस वजह से. So let me have a look at the chat first. Jalid, I don't understand how you're comparing it with that. Could you explain that?
Sir, dendrograms में जब हमने splits की basis पे we were doing market segmentation.
Yes.
So I was just relating it to that कि हम देख रहे थे कि उसमें ज़्यादा कितना ज़्यादा distance कितना ज़्यादा था, and then we were drawing lines कि okay, this is a new segment. But I don't know if that's a correct.
No, so the logic is very similar. Yes. So it's not directly related to that, but yeah, the logic is indeed very similar. Yeah.
Okay.
Achha, so the second thing that you would actually be doing in practice is that you choose this thing called post pruning. This cost complexity pruning bhi kehte hain. What this means is, so again, I'm not going to go into too much detail here. So it's a bit mathematical, especially this where this alpha comes from and this formula here. But the idea is that to counter that problem of having good splits after some poor split, आप करते ये हैं कि you build complete trees. ठीक है, so complete tree would mean the trees that are built based on these two conditions, that you keep growing the tree until one of these two conditions is met. You have no more features left, or you have all training data correctly classified. Until you achieve either of these two conditions, you keep growing the tree further. Okay, so once you do that, that's called a complete tree. कि आपने regardless of the information gains, आपने जितनी भी information gain है, आपने पूरा tree build कर लिया. And then what you do is you basically try different cuts of that trees. कि आप, for example, if you're starting from the top और आप ट्री बिल्ड कर रहे हैं और आपने पूरा एक ट्री बिल्ड कर लिया, मैक्सिमम ट्री जितना आपने बिल्ड कर सकते थे, अब उसमें से what you could do is you could cut out different parts of the tree. आप नीचे से different branches उसका cut करना शुरू कर दें, and when you cut those different branches, each of those cuts is going to give you a different tree, right? आप नीचे से cut करना शुरू करेंगे different sides से, तो so आपको कोई जो है वो एक different split देगा, कोई आप हर cut आपको एक different जो है वो tree देगा as a result. ठीक है? And then what you do is you consider all of those different trees जो आपने उसमें से different cuts के बाद आपको जो different trees मिले. So let's say you have 500 different trees from that. What you would do is you would train your model on all of those trees, और आप उसको validation data के ऊपर जो है वो test करेंगे. ठीक है, validation data के ऊपर आप उसको validate करेंगे. Whichever of those trees gives you the best result, that is going to be the tree that you would choose as your best algorithm, right? So यहाँ पे जो T naught है, यहाँ पे T naught is that complete tree that we're talking about. Alpha is basically a constant that is used to assign some sort of a penalty for the tree size, because again, to avoid that problem of overfitting, what we want to do is कि हम बहुत ज़्यादा जो है अपना tree का size जो है ना बड़ा नहीं रखना चाहते, because that is going to increase complexity. That's the first thing, and it's also going to make it more likely to have this problem of overfitting. So हम एक penalty assign कर सकते हैं, एक alpha value आप यहाँ पे assign कर दें. That it could also vary. आप जो है वो 0 से लेकर start हो जाएं. You keep on increasing it. Let's say some bigger value. So let's say 0, 0.001, 0.002, and so on. और आप वो loop लगा के you could check for different values of alpha, different penalties के साथ on the size of the tree. और ये जो आपके left side पे, this is what you have. This is the purity measure that we were already using earlier. इसके साथ आप इस penalty को use करते हैं और इस पूरे number को आप minimize करते हैं. Now this formula itself is very mathematical in the sense कि इसके background पे the proof and all, we cannot go into the detail there, but you should have an intuitive understanding like this कि postponing का मतलब क्या है. You will basically building a complete tree first, और उस complete tree में से you will be cutting different parts of it and generating a lot of different trees, and then you will be validating those trees on the validation data and choose the one that gives you the best result on the validation data. Okay, so that's how you build it in practice, right? So in the few minutes that we have left, let me just discuss what you would do in regression trees. So classification और regression trees में difference क्या है? Your outcome variable in this case is going to be a numerical value. So again, हमने वो तो discuss कर लिया already कि आपके पास जो predictors हैं, जो input variables हैं, they could either be classification variables or numerical variables, और उन दोनों को हम किस तरह से handle कर सकते हैं. So everything there remains exactly the same. The only difference is कि आप एक तो impurity measure कैसे कौन से use करते हैं. So we no longer can use entropy or Gini's index in case of numerical outcomes. So that's the first thing. And then the second thing is, instead of the majority value, the majority outcome, we have to use something else as well, because यहाँ पे there's no concept of majority voting in numerical outcomes. So सबसे पहले हम ये second point को पहले देख लेते हैं. The purity measure, we basically use the mean squared error for this. So for each node, हम वहां पे देखेंगे जो भी आपको split जो है best सबसे कम mean squared error दे रहा है, that's what you're going to be choosing. ठीक है? So जो भी आपको split सबसे कम mean squared error दे रहा है, ये सबसे ज़्यादा improvement दे रहा है from parent to the child, that is the one that you're going to be using. So instead of the entropy measure or the Gini's index measure, you're going to use mean squared error in this case. And then your predictions in this case are going to be based on the average outcomes in that particular node. So let's say आपके पास for example यहाँ पे in this case, in this tree, let's say instead of from these 12 values, आपके पास in categories के बजाय आपके पास 12 different numerical values हो सकती थी in observations की. तो आप क्या करेंगे, उन 12 observations की average ले लेंगे, and that will be your prediction at this particular node, right? And then you'll be testing this prediction using the mean squared error and checking which split gives you the least mean squared error. ठीक है? So the concept is fairly similar here. आप सारे different variables, जितने भी आपके पास variables हैं, सबको check करेंगे, सबको test करेंगे, whichever of them gives you, whichever split gives you the least mean squared error, that is the one that you're going to choose first, and then move on in a similar way. ठीक है? So that's the only difference in case of regression trees, right? So यहाँ पे सिर्फ ये difference आएगा regression trees के case में. अच्छा, now the problem is कि आपके पास in trees के case में ना, you have a lot of variance, and that is because अगर आप different training data आप use करें ना, so for example आपके पास आप randomly assign कर रहे होते हैं ना training data, validation data and test data, आप randomly choose कर रहे होते हैं. If the random splits were different, for example आप एक दफा एक 60% data choose करते हैं, एक और दफा 60% data choose करते हैं, now those random splits could give you two very different training data sets, right? Regression trees के case में या classification trees दोनों, decision trees के case में in general, आपकी variance काफी high होती है. That means two different training data sets could give you very different trees. और उसकी interpretations काफी vary कर सकते हैं. Your predictions are, your prediction accuracy is still going to be fairly good and fairly similar in the different cases. लेकिन जिस तरह से वो tree build हुआ होगा ना, for example, the variables that you are choosing as choosing first, they may vary a lot across different choices of training data splits. उसकी वजह से वो बहुत ज़्यादा जो है वो vary कर सकते हैं. So you actually have a lot of extensions to these trees. Okay, we cannot go into details here because we do not have much time left in our course. But you will see different extensions to these trees. जिनको हम जो है कुछ एक bagging कहते हैं. Then bagging के साथ you have another term called boosting and bootstrapping. And then you also look at something that's called random forest. This is also something that's used very frequently in practice. So when I upload the slides, I'm also going to include this part in the slides. So if you are interested, you can go through these slides as well and choose to look at the book chapters as well, जो आपके पास यहाँ पे mentioned है. You have these books uploaded there. So if you're interested, you can go through these algorithms as well, because these are also used very commonly as extensions to those simple decision trees that we've discussed. And these actually solve a lot of issues that those simple decision trees have. So in practice, you will see they are used very commonly. Bagging and bootstrapping, and you have boosting algorithms, you have ensemble methods, and this is also very common, the random forest trees. This is also very common. So if you're interested, I would recommend कि आप एक दफा slides go through के, maybe after exams, and you may choose to look at the book chapter as well. Okay, but this is not going to be part of your exam. ये जो extensions वाला part है यहाँ पे, this extensions wala part, that's not going to be part of your exams. Okay, so in the next session, I will be answering any, in fact, I'll be answering any questions right now. We'll stop for today, and we'll just discuss quickly before we start the next thing. We'll be discussing the advantages and shortcomings of decision trees very shortly, and a couple of real life applications that it has. Okay, so we'll stop here for today. So those of you who want to leave, you can leave. We'll not be doing anything new, and I'll be here for answering questions for the next, let's say, 20 minutes or 30 minutes or so. So any questions? I hope it was all fairly intuitive, but of course, the first time you do it, it is quite a lot to grasp. So you should try to go through it once by yourself as well. Any questions? या तो सब कुछ बहुत क्लियर था, या फिर कुछ समझ नहीं आया. कौन सा केस है इन दोनों में से?
Sir, I wanted to ask about information gain कि उसकी value जो है वो क्या define करती है, मतलब अगर ज़्यादा है तो what does that mean, and if it's less, मतलब I know कि उसकी basis पे हम उसका formula भी मुझे समझ आ गया था, और किस तरह हम split कर रहे हैं उसकी basis पे, but what does it basically intuitively mean, a higher or lower value?
Let's look at this split. You have this split right now. Let's look at this node that's below here. Critical success कितने हमारे पास 1 है, mainstream hits भी 1 है, box office bust भी 10 है, right? Now there's a certain information that you have in this node. 10 out of the 12 are box office bursts, 1 out of 12 are this, and 1 out of 12 are mainstream hits. Now, if you were to split this further, like this, अगर आप नीचे A-list celebrities के basis पर इस part को और divide कर लेते हैं, what do you get? आपके पास right side पे जो ये वाला quadrant है, you get box office bursts that are 5 here, and you have on the left side as well, you have box office bursts that are 5 here. Are you getting any useful information from this split, Jalid?
No, sir.
Why is that?
Sir, जो आपने जो A-list celebrities वाला किया है या फिर
so let's look at this. Let's look at this one. So okay. Let me go to the tree instead. So let's say I have this tree here. Okay. And ये node है, ठीक है. Let's say I don't stop here. यहाँ पे अभी इस tree में तो I have just stopped here, right? So let's say instead of just stopping here, what I do is okay, now instead of this, I do this. Just give me 1 second. Okay, so I'm going to draw the tree here a bit differently. So let's say मैं यहाँ पे इसको further split कर लेता हूँ. Again on budget. Okay, so I don't stop there. I choose to split it further on the basis of budget. So I have either a low budget or I have a high budget. ठीक है. अब इस केस के अंदर I have two possibilities here. अच्छा, ऊपर वाले इस नोड के ऊपर these are the values that I'm getting, right? 10 box office burst, 1 mainstream hit and 1 critical success. What happens in this part? अगर आपका budget low है, तो in this case I'm actually getting 5 box office bursts, and I think that it was 1 critical success. And on this side, I'm getting 5 box office bursts and 1 mainstream hit. Okay, so this is the other option that I have. Okay, यहाँ से next step पे move जब मैं करता हूँ, this is the result that I get. कि ये वाला जो 10-1-1 है, it splits like this, 5-1 here and 5-1 here. Now, it's not really giving me much more useful information as compared to what I already knew about these values here and in the earlier node already. So यहाँ पे इस वाली node पे I already had some information about these values के इनमें से majority box office bursts हैं और I can categorize all of them as box office burst. अगर मैं इसको further categorize करता हूँ, again I get a box office burst majority in this case as well. और यहाँ पे इस case में भी I still get a box office burst majority here. So I'm not really getting much extra information from this split. So information gain जो है ना, इस चीज को जो हम intuitively एक चीज understand करें कि अच्छा हमें extra information नहीं मिल रही, इसी चीज को quantify कर देता है, right? So the higher that value of information gain is, उतना you understand कि इस node को further split करने का हमें उतना ज्यादा फायदा है. So let's say अगर आपको इस split का यहाँ पे information gain was 0.2 या 0.02, in almost all cases this is a fairly low number because it's very close to 0. That means आपको ये split करने से कोई बहुत ज़्यादा extra information नहीं मिल रही है, right? That's what information gain intuitively means कि आपको उस split से यहाँ पे जो ये वाली जो nodes है नीचे वाली, वो कितनी extra information दे रही हैं आपको as compared to this parent node. तो अगर वो आपको इतनी extra information नहीं दे रही, you would just stop there at the previous node and not split any further. Does that make sense, Tareed?
Yes, sir. उससे समझ आ गई है कि like if it is a very lower information gain expected from the split, then you won't really make the split. That's
Yes.
where you will cut off the variables. और अच्छा, so दूसरा जो concept था about I forgot the name, cutting या so उसके अंदर we are pre something, it was the name. So we're basically
pre-pruning and post-pruning.
Yes. So pre-pruning में वो because obviously उसमें we aren't doing it because we don't recommend doing it because we might lose some information if we have a classification already defined. So अगर हम
okay, so let me explain. So let's say you have 12 variables, right? So let's say 10 variables in your data, and you start splitting your tree like this. Okay, you split on the first variable, whatever that is, you split it like this. Then you have another variable, you keep on splitting. Then let's say at this point, the information gain that you're getting for the next step is very low. Let's say it's 0.01. Let's say आपके threshold से वो बहुत कम है, ठीक है? So you may choose to just stop at this point. in terms of growing the tree further from this point onward. You would just stop at this point. इसमें problem क्या है? You haven't seen what comes after this. कि आप जब उसको further split करते, maybe in the step that comes after this, आपको एक बहुत अच्छा split मिलता. That would be useful for your classification. अब क्योंकि आपने वो build ही नहीं किया, you are blind about that. You don't know anything कि what will happen after that. So that's why pre-pruning is not does not give you very good results. कि आप you're blinded because you have not even seen what comes after that. Post pruning में क्या होता है? You keep building the tree regardless of whatever information gain you have. You keep building the tree as much as you can. और फिर आपको एक तरह से visibility पूरी मिल जाती है पूरे tree की. And once you have that visibility, now you can choose, you can start cutting different parts. और फिर आप देखते हैं कि अच्छा कौन सा subset जो है उस tree का आपको best results देता है on your validation data. So now, Jaleel, can you ask again if you're still confused about this?
No, sir, I understand it. Thank you so much. जो post pruning है तो उसके अंदर because we get all the information या उससे हम data को completely visualize कर सकते हैं. तो उसके बाद do we then categorize कि okay here we have a lower information gain, so we may not go further into this detail. It's not pre-pruning में तो we are not even visualizing the entire data.
Yeah. So if in this case, so actually what happens is there are many variations of this. Okay, so what we have done earlier, जो इसकी basis पर हम ये information gain की basis पर divide कर रहे हैं, this is one variation, right? Then what you get out of this post pruning, this is another variation. So ये बहुत सारी different variations exist करती हैं when you actually are building these algorithms. So the idea here is to just give you some introduction in the sense कि आपको जो है कुछ taste मिल जाए कि अच्छा क्या चीजें जो है use होती हैं to build trees like this. आप जब different models को देखेंगे ना, when you actually do it in some language, let's say R or Python, you would see कि ये सारी different जो है ना options available होती हैं कि आप इनमें से कोई भी choose कर सकते हैं. Then you test all of them on the validation data and then you see कि अच्छा कौन सी जो है वो आप loops लगा के check करते हैं या कुछ आपके पास जो है वो standard libraries होती हैं that do all the work for you. उनको use करके you actually test everything on the validation data and then you choose whichever model gives you the best result. So that's the thing about machine learning कि कोई भी जो है आप जो है ना पहले से decide नहीं कर लेते कि अच्छा this is the best thing, that this is the thing that's going to work best on a particular data. आप जो है उसको test करते हैं on unseen data practically and then you rely on the evidence कि अच्छा कौन सी चीज जो है वो सबसे बेहतर work कर रही है. Does that make sense, Dalit?
Yes, sir. Thank you so much.
Okay. Do you have any assignment due?
Sir,
Dalit, आप लोग किसी भी कोई भी और assignment अभी कोई deadline तो नहीं है अभी कुछ?
Sir, there are a few of them.
Okay, so because people left very quickly, unlike earlier times. तो मैं बस
Sir, I think there is this proposal that is due, तो शायद वो कर रहे होंगे.
Right. ठीक है. चलें, let's meet on Thursday then, and I think we have no other questions, so we'll stop. Any other questions? Those of you are still here. Arham, Myra. अरहम, आपने डेटा कैंप पे कितना कर लिया और कोर्सेज ले रहे हैं आप कोई?
Sir, I think अभी कोई भी नहीं है लेकिन मैं पूछ लेता हूँ. So what is leaf node? ये मुझे नहीं समझ आया था उस टाइम. मैंने सोचा था मैं बाद में इसको दोबारा पढ़ूंगा.
Leaf node is that
The
when you
baby
have
node.
reached the final yes, so it's a node that does not have any child basically. What you have at the
Okay.
end, just the final prediction है. ये final
Okay.
so आपके पास दो different types हैं. ये आपके जो rectangles हैं, these are decision nodes, and these ovals here, these are your leaf nodes, which do not have any further children, which cannot be divided further.
Okay, sir.
Okay. Okay, Jalil, do you have any other question?
No, sir. I
Okay.
will review everything and then maybe. So thank
Okay.
you so much.
All right, no problem. Okay, so we stop here and let's meet on Thursday then. Allah Hafiz.
Allah Hafiz.